Hello everyone, welcome to Nishta Ias Prelims Express Day 2 of Geography. I hope all of you are enjoying the video and taking the tests. Don't forget to take the test regularly. That is a part of preparation and the most important part. And here are some of the current affairs topics for geography, and in that, so we have some of the one-worders, some of the conceptuals and many others. So we will make sure we'll brush up those which are in current affairs and also which are conceptually related to geography. And now here is a question of PYQ. Friends, many students, they made this question wrong because the greenhouse gas effect was not thorough with you. And we will see how the greenhouse gas actually occurs. Say for example, this is the earth and around the earth this is earth's atmosphere. अब atmosphere में क्या होता है? So atmosphere has a very unique property that whenever a short wave radiation that passes through the atmosphere, so atmosphere allows this short wave radiation. And whenever there is a long wave radiation that hits the atmosphere will not allow the long wave radiation, it will trap the long wave radiation. So now what is this short wave radiation and long wave radiation? Friends, whenever a body is hot, so now at its lower temperatures of heatness, it will emit the waves of longer radiations. Say for example, best example for this is take an iron and heat it. So as and when you start heating, it looks reddish hot in color. So now that reddish color is an emission of red wave, that is a longer wavelength. So in your VIBGYOR, you have seen in the VIBGYOR, the red part has the longer wavelength and then the violet part has the shorter wavelength. So now the reddish part started emitting, and now heat the object more. As and when you heat the object more, so then we start getting the whitish coloration of the iron. So that whitish coloration is because, so along with the red waves, other waves are also being emitted. So your blue, green, yellow, all these get emitted. That is why the whitish in color. That means as and when the object gets heated more and more, so we start getting the whitish color or the lower wavelengths. So they also start emitting. That means, so we can deduce that as and when the objects get heated, so then the shorter waves start emitting. So lower the temperature, longer the wavelength, higher the temperature, shorter the wavelength. So now compare the sun and the earth. Friends, sun has very high temperature, so we can say sun emits very shorter wavelength. So now the sun's radiation, so they passed through the atmosphere because atmosphere will allow the short radiation to pass through. So now this short radiation was absorbed by the earth. As it gets absorbed by the earth, so now earth gets heated. As the earth gets heated, so now earth starts to emit the radiation. लेकिन earth उतना heat नहीं है जितना sun को है. So earth is not as hot as the sun. So now earth emits the longer radiation because it is having heat but considerably less. So now this longer radiation which is emitted by the earth is trapped by the atmosphere. That is called the greenhouse effect, and because of this trapping, the whole atmosphere gets heated. So here we can see that the atmosphere is heated more by incoming solar radiation than by the terrestrial radiation. So here the statement says the atmosphere is heated by the incoming solar radiation, which is false. It is more heated by the terrestrial radiation which is trapped and not the incoming solar radiation. And carbon dioxide and other greenhouse gases in the atmosphere are good absorbers of long wave radiation. Yes friends, to some extent the whole atmosphere, so it traps and absorbs the long wave radiation. So hence the carbon dioxide and others, they are the good absorbers of the long wave radiation. Then similar questions repeat many times, friends. Here is one more question. Consider the following statements. Without the atmosphere, temperature would be well below freezing point everywhere on the earth's surface. So here is one more concept to be discussed. So here it says that what if the earth without atmosphere? What is the condition of the earth without atmosphere? So now I take only the earth and sun, and now say there is no atmosphere in between either to allow the short wave or trap the long wave. So now as and when the sun's radiation emits, so the direct radiation can come and they can hit on the earth. So if there is no atmosphere, so at least this part of the earth will be heated. So that means if there is no atmosphere, we cannot say that there will be freezing point everywhere, but those part which is exposed to sun, that is that part of the earth which is exposed to sun, that will be heated at least. So that is why this statement becomes wrong. And second statement, heat absorbed and trapped with the atmosphere maintains our planet's average temperature. So heat absorbed and trapped by the atmosphere maintains our planet's average temperature. Yes, it is the absorbed and trapped sun rays that is being heating the atmosphere, and that is why it is distributing throughout the atmosphere. Hence the average temperature is maintained. Then atmosphere's gases like carbon dioxide are particularly good at absorbing and trapping radiations. Yes, the same statement which we saw here, the second one came back here. So that is why there are some favorable topics of UPSC if you are very thorough with that. So these topics keep on repeating. As I spoke last year, these are like your UPs in your election. So just say for the Lok Sabha election UP, if it stands up and gives the majority, so automatically the party becomes the victorious one. Hence the same way, so catch hold of geographical concepts very thoroughly. Then coming to the composition of atmosphere, friends, you all know during your childhood also you have studied. So here is nitrogen, which has 78.8%, sorry 08%, then oxygen 20.95%, and remaining 0.93% is by the argon. So friends, argon forms a significantly larger component compared to other gases. Although it is an inert gas, it is having a great contribution to the atmosphere. And then we have the other permanent gases, that means which remain in the atmosphere for longer durations. We have neon, helium, hydrogen, xenon, etc. That means apart from hydrogen, others are the inert gases. Then we have variable gases, that means the composition of these gases vary, and because of the natural and anthropogenic reasons, the composition varies. Say for example, water vapor, it can vary from 0% to 4%, and carbon dioxide, it can also vary, but so usually it will be 0.038%, very less. And methane, nitrous oxide, ozone, chlorofluorocarbons, so all these are also very minute ones. Friends, usually sometimes the questions are asked that which are the secondary pollutants of air. Friends, secondary pollutant means either it will be a catalyst or a secondary agent in some of the chemical reactions, or they will be very small in quantity that they cannot become the primary pollutants. Yes, likewise. So whenever the question occurs on secondary pollutants, remember, like they are the secondary reactants in the chemical reaction, and then they are present in very minuscule quantity. That is why they don't form the primary quantities, primary pollutants. Then come to next, the triple dip La Nina. Friends, this was in news because we have been experiencing triple dip La Nina from last 3 years. So what is a triple dip La Nina? It is a continuous propagation of La Nina continuously for 3 years. So because of that triple dip La Nina, India has experienced a peculiar trend in air quality. So what is that? So here, because of triple dip La Nina, so there is a dominance of higher northerly winds, and the trapping of pollutants increased in the peninsular India. That means friends, in the winters, usually the North India has more pollution. But this time, because of triple dip La Nina, we have more pollution in South India. It is simply because the northerly wind, they flushed or pushed all the pollutants towards the south, and in the south, so they got trapped. And then weaker western disturbances and absence of winter clouds led to significant improvement in air quality in the north. Friends, in the north what happens was, in the winter you get western disturbances. Western disturbance give the rainfall and the clouds. And so in the La Nina means we have more summer rainfall. Because of more summer rainfall, the winter rainfall compromises. As the winter rainfall is less, the cloud formation due to western disturbances is less. Because of less cloud formation, there is less smog formation. Because for the formation of smog, we require humidity as well as pollutants. And now we know that pollutants are being flushed from the north towards south by the northerly winds, and also that there is no moisture to create the smog. Hence, the air quality improved in the north. But as and when the pollutants got flushed out to the south, southern India got bad air quality. And hence, triple dip La Nina reversed the air quality trends in India. Then, usually what is triple dip La Nina? It is a La Nina which lasts for 3 years in a row. And it is nothing but the La Nina which happens usually because of the ENSO, that is El Nino Southern Oscillation. Friends, here we see what is El Nino. So usually we have the wind blowing towards the South American coasts, and because of this, several natural phenomenon like the upwelling of nutrients here in the Peru coast and the descending winds here, so all of them gets shattered, and hence we will be having rainfall here where it is not needed, and we will be having less rainfall here where it is actually needed. And then La Nina, friends, La Nina is nothing but the profound implementation of the usual flow of the wind. The wind blows from the Peruvian coast towards the Japanese coast, and here there is upwelling, there is good amount of fishing, and as there is descending wind here, so obviously there is winter which is conducive, and the people want winter here. And here we have the rising winds where the rainfall occurs and people want rainfall here. So this is how the circulation goes. So I don't need to explain you the El Nino and La Nina, only a brief revision for that. Then next one, earthquake zonation. Friends, so Government of India came up with a new earthquake zonation map, but various restrictions, mandates, etc. were stipulated, and there were lobbying and protests also went against that, saying that this earthquake zonation makes the building constructions almost impossible in the Himalayan ranges, and because of that the zonation was taken back, backtracked, government backtracked in this issue. So that is why what was that zonation and how it was different, we will see. So here we can see a very high risk zone is being stipulated on the Himalayan regions along with your Andaman Nicobar and your Gujarat coasts, and we will see some of the differences. Friends, the updated map was issued by the Bureau of Indian Standards as a part of the revised Earthquake Design Code 2025. So BIS, that was the authority to issue this zonation map, and it uses internationally acceptable probabilistic seismic hazard assessment method. So PSHA method was used here. Then the key features of the revised zonation map. First one, introduction of high risk zone, that is zone 6. Friends, the entire Himalayan arc including the Jammu Kashmir, Ladakh to Arunachal region were placed in the zone 6 area where it is showing the highest risk, and it recognizes consistent and extreme tectonic stress along the Indian Eurasian plate boundary. And here on an average in moderate zones 2.6% of India is now in moderate to high risk zone of earthquakes, and some of the towns which are located in the boundaries of the plate tectonics, so they are being upgraded to high risk zones. Earlier they were in the moderate risk zones and now they are being upgraded to high risk zones. Yes, likewise. Then inclusion of rupture propagation southwards. That means, friends, like there are chances of the earthquake plates or the plate tectonics, then inclusion of the rupture propagation southwards. That means, so the map acknowledges that Himalayan frontal thrust ruptures may extend to south, and that is to the populated foothills of the region like Dehradun. The next one, inclusion of the rupture propagation southwards. That means the map acknowledges that Himalayan frontal thrust ruptures may extend south to populated foothill regions like Dehradun. Friends, here the point says that, friends, here the map shows that the Himalayan plates, so that might rupture, and the ruptures or the cracks, so that might extend southwards. Say for example, here is the Himalayan region, and towards south if they extend, so that will also reach the foothills and down to the foothills, that is near the Dehradun or maybe the Terai region, whatever we call. That means even these regions are having the risks of earthquakes, and hence building construction becomes difficult even in the Terai and Dehradun regions. And then the map also stipulates, friends, and then along with the zonation map there were several rules and regulations that were stipulated. That is, mandatory structural and non-structural safety measures have to be taken up for construction of buildings in the earthquake hazardous zones. Then new soil and ground response requirements are needed. That is, the rule says that there should be a detailed provisions for the liquefaction, soil flexibility, and site-specific shaking maps, etc. Friends, what is liquefaction? It is simply that, so whenever the earthquake occurs here, and when the soil is very liquid or might be the soil is very loose, then the earthquake waves propagate through this loose soil to the other regions as well. The best example of liquefaction is your Delhi earthquake. Friends, whenever there is earthquake in Nepal, that waves of Nepalese earthquake, so that will be travelled straight away to Delhi, because between Nepal and Delhi the soil is very loose, and that is why the liquefaction occurs. So hence while you construct the buildings, your soil flexibility, liquefaction and site specific shaking, all those things should be observed. So as the rules became so much stringent, so there were lobbying on this. That is why the report was backtracked or it was repealed, we can say. The new report comes, and whenever it comes we will see what new things have come. But however, as Himalayas have seen so many earthquakes, so that is why this map also becomes very much important. And then northeast monsoon. Friends, so overall monsoon is very much important for us, and here we can see that monsoon occurs because of the shifting of the ITCZs. Say here we have the Tropic of Cancer going, here we have the equator, and in the equator we have ITCZs. Because of the shifting of ITCZs, so the ITCZ will take a curve like this, and after some time, so the curve can become like this. So it can crunch here and it can make a trough like this. So that means here the ITCZ forms a low pressure and high temperature zone. This low pressure and high temperature zone that will move northwards near UP, where it forms the monsoon trough. And because of this monsoon trough, so there is a contrast of heat created between the ocean and the land, and hence the land now draws water and moisture from the ocean, and because of this the monsoon occurs. So now it is drawing moisture from the ocean, and now the moisture comes, and now the monsoon splits into two branches, that is the Arabian branch and the Bay of Bengal branch. And this Bay of Bengal branch, so that gives rainfall for your Kolkata, West Bengal and northeastern region, and the Arabian Sea branch, so that will pass through Karnataka, Maharashtra, and then it enters from Gujarat, and then it gives rainfall for the Rajasthan, Punjab, Haryana region. Friends, here we have to note that the Bay of Bengal branch also comes across a carom board like structure in the northeast. Friends, here we have the northeastern Himalayas, and then here we have the Arakan mountains. So now the Bay of Bengal branch comes here, and just like the carom board pouch, whenever you hit the pawn to the corner, it rebounds multiple times. So here also the moisture laden winds, they shuttle to and forth through this pouch, and that is why they shed maximum humidity here, and that is why this place becomes the wettest place in the world. That is why we have Mausinram, Cherrapunji, etc. in this region. That is why northeastern Himalayas, they get very heavy rainfall. Yes, likewise. So remember how the local geography matters for the rainfall distribution as well. And then, so apart from the southwest monsoon whichever we discussed now, we should also discuss the northeast monsoon. Friends, northeast monsoon is obviously a cold dry wind that passes from Chinese land into the India. But however, Himalayas, they will block them, thereby reducing the coldness of those monsoons. But however, some of the air, so they will pass through and they will enter into the Bay of Bengal, and some of the air, they also pass from the Indian mainland to the Arabian Sea. But come to this geographical area where the Bay of the northeastern monsoon, they will pass from the land to the Bay of Bengal, and in Bay of Bengal they carry some moisture, and the moisture laden winds, so they will enter this part of the Coromandel coast. And because of this traveling of wind, that is moisture laden wind from sea to the land, so now the Coromandel coast or the Tamil Nadu receives the northeastern monsoon. And this northeastern monsoon is a significant rainfall getter for Tamil Nadu. And friends, we can remember in NCERT we have a statement that Kaveri is a perennial river despite being in South India. Why? Because say Kaveri flows from Karnataka to Tamil Nadu. So half of Kaveri gets the water inlet from the southwest monsoon from Karnataka's western Ghats, and the remaining half of Kaveri gets the rainfall from the northeast monsoon from the Tamil Nadu coast. Hence, because of its geographical location, Kaveri is considered a perennial river because it gets the water inlet throughout. Yes, likewise. So remember southwest monsoon, northeast monsoon, and why Kaveri is a perennial river. And friends, apart from this, we also have the role of jet streams in the monsoon. How the jet streams work? Friends, they work on this fashion as shown in the figure. So here, the jet stream, they have a roller coaster path, so around the equator, and they travel usually in the upper atmospheric layer, that is on the top of troposphere they travel. And friends, here we can see the direction of the jet streams. Here what happens is that, so we have the westerly jet streams which are coming from the westwards. So these westerly jet streams, they will push the trough, that is the core region of pulling the monsoon towards the ocean, and as it pushes towards, the monsoon weakens. That is why whenever the westerly jet stream comes, so it will weaken the monsoon, and westerly jet stream, they will be profound in the winters, and that is why westerly jet streams, they bring western disturbances. So western disturbances, they are the winter rains which will come to the northwest India, and your westerly jet streams they have a significant role on this. And then whenever the easterly jet stream, so that is in motion, so now the trough is pushed towards the mainland, that is UP region or the Tibetan region above. So that is why when the easterly jet stream, so that comes into action, we will be having profound rainfall, and when the westerly jet stream is in action, we will be having winters. So remember the role of easterly jet stream and the westerly jet stream. So this is a brief about Indian monsoons, and here we can see the description of northeast monsoon. It occurs in October to December, and it brings moisture from Bay of Bengal, thereby giving rainfall on the Tamil Nadu coasts. Then the thirst waves. Friends, what are these thirst waves? Friends, global warming is making the air thirstier, and thereby causing higher evaporative demand that dries out the land and plants. That means whenever a dry wind comes, so now it draws the moisture from all around, and hence that is called as a thirst wave or the thirst wave of air. It is not a wave of ocean, it is a wave of air. Yes, likewise. Thirst wave term coined by researchers, it referred to a period of 3 or more consecutive days with extreme atmospheric evaporative demand. Friends, when the thirst wave comes, so even you feel dehydrated, so your skin becomes very, very dry. So that is also an indication of thirst wave. Yes, likewise. The causes of the thirst wave, they are influenced by temperature, high temperature, lesser humidity, and high and direct solar radiation, then high wind speed, which will carry away all the moisture. And unlike heat waves, hence thirst wave have various causations, unlike the heat waves, which are mainly because of your temperature and the wind. That means your heat waves do not consider humidity or the radiation of the sun into consideration. Friends, in other words, we can say that your thirst waves, so they are more a complex phenomenon rather than the heat waves, which are simply because of very high, which are caused simply because of very high temperatures. Then, how to measure the thirst wave? It is measured through short crop evapotranspiration. That means the measuring of the loss of water in a well watered 12 centimeter grass surface. That means we have a grass surface and the thickness of the grass surface is 12 centimeter, and when the wind blows, how much water is evaporated on this grass surface, that is being calculated to identify the thirst wave. Then, rising evapotranspiration indicates higher temperatures, lower humidity and increasing wind speed, which we already discussed. Then the impact of the thirst wave, that is the loss of moisture of the soil, and then the requirement for greater irrigation, and the higher risk for the crop loss and lesser in yield, the higher risk of crop loss and the reduction in yield. Then the studies show that evaporative demand is increasing in India. That is including in northern India and western India. We have increased occurrence of the thirst waves, and even in future there are high chances that such thirst wave increase frequently, and thereby rising the evaporative demand and drawing all the moistures wherever the wind blows. Then coming to next, the global geoparks network. Friends, recently some 16 global geopark networks have been identified by the UNESCO, hence it becomes important. So what are these global geopark networks? These are single unified geographical areas where sites and landscapes of the international geological significance are managed with the holistical concept of protection, education and sustainable development. So itna zaruri nahi hai. What are these geographical networks? So these are the single unified geographical areas with of high biodiversity and environmental importance. Then these comprise a number of geological heritage sites which have scientific importance, rarity and beauty. Then the UNESCO Global Geopark designation was created in 2015, and it recognizes the geological heritage of international significance. And this UNESCO's Global Geoparks Network is not a formal legislative designation, but however, they must be protected under the local or regional and national legislations. That means there is no international law to protect these global geopark networks, but we have to protect them through our national and regional legislations. And also, the status of global geopark network doesn't imply the restrictions on any economic activity. So that means we should not be restrictive, rather we should be conservative. That means our environmental conservation and some of the human activities should go hand in hand. Then, recognition period. The global geoparks network, they are recognized for a period of 4 years, after which the functioning of the site is re-examined during a revalidation process. Then some of the restrictions exist, that is the selling or destruction of geological value of UNESCO sites, they are not permitted here. That means you cannot destroy the value. And then the Geoparks Network, it is a non-profit international association officially established in 2014 subject to French legislation. So France was instrumental in bringing up this Global Geoparks Network, and it is officially this association is the official partner of UNESCO, and hence the UNESCO Global Geoparks Network. So remember friends, the Global Geoparks Network, it is run by a non-profit international association which is powered by the UNESCO. Then coming to next, polymetallic sulfides. India has secured International Seabed Authority's license to explore polymetallic sulfides in the Carlsberg Ridge of Indian Ocean. Friends, earlier we had got the permission for the polymetallic nodules in the central Indian Ocean basin. and now we have got the permission for the polymetallic sulfides in the Carlsberg Ridge. So now India's new exploration rights, what are those? So the agreement with Jamaica-based International Seabed Authority. So remember, the ISA, International Seabed Authority's headquarters is in Jamaica. So there was a question on International Seabed Authority. So remember this. And then, so what are these polymetallic sulfides? These are the nodules which are rich in manganese, cobalt and nickel and copper and other minerals. They are critical for battery, renewable energy and other high-tech infrastructures. And so the license marks the first license globally issued for such exploration in the Carlsberg Ridge. Friends, Carlsberg Ridge is a serene and eco-sensitive zone. Might be this is the first time a license has been issued for the deep mining purpose. And then this contract, and then friends, what are the duration of these contracts? So the contract for the polymetallic nodules which we got earlier, that will end by 2027, and for the polymetallic sulfides which we have got now, that will end by 2031. And then here we can see the Carlsberg Ridge. So this goes the Carlsberg, and here we have Africa, and near to that locate Seychelles, Madagascar and Gulf of Aden here. And then the difference between the polymetallic nodules and the polymetallic sulfides. Friends, nodules are typically found on the abyssal plain at the depth of 4 to 6 kilometers. So earlier we got, friends, these are the polymetallic nodules for which we got the permission earlier, and they are present in the abyssal plains, and they are composed mainly of manganese, iron and silicates, and they are formed through the precipitation of metals from seawater and are rich in trace metals such as nickel, copper and cobalt. Anyway friends, composition we don't think they will be that different. Basically remember here, that is about the abyssal plain. And then polymetallic sulfides, they are found at the shallower depth. They are formed by precipitation of metals dissolved in seawater at hydrothermal vent sites. That means these are formed in the hydrothermal vents. That means for the polymetallic sulfides to precipitate, we have to have a high temperature thermal vent. So that is why the name hydrothermal vents. So friends, you are geysers, and these are the areas where we have hydrothermal vents. So in that region, whenever the metals precipitate, we get the polymetallic sulfides, and in other regions we get polymetallic nodules. And they are typically composed of iron pyrites, but contain varying proportions of other metals like pyrrhotite, then fluorite and galena. And copper and zinc are the most likely metals to be recovered from these deposits. So remember, for the polymetallic nodules, nickel, copper and cobalt, and for the sulfides, copper and the zinc. Then come to next, Bharat Forecasting System. Ministry of Earth Science unveils Bharat Forecasting System, one of the world's first indigenously developed high resolution weather forecasting system. So remember, first indigenously and high developed. Then it is developed by the Indian Institute of Tropical Meteorology, that is IITM Pune. It enhances India's weather prediction resolution from 12 km to 6 km, enabling location specific forecasts. So earlier the weather was given for 12 kilometers, and now for every 6 kilometers we have different weathers. Then it integrates systems with the real-time inputs from 40 Doppler weather radars, thereby improving accuracy. Friends, Doppler radars, they are used for weather forecasting, and your Doppler radars, they use Doppler effect. So you know the Doppler effect, as and when a body which is creating the sound, as and when it approaches you, so the frequency increases, as and when it moves away from you, the frequency decreases. Hence such radars are very useful for tracking a moving system, and weather, cyclone, all these are the moving system, hence they are more suitable. Then significance of this Bharat forecasting system, it produces forecasts within 4 to 6 hours. Earlier it used to take 12 to 14 hours to get the weather information forecasts. And this Bharat forecast system, it positions India ahead of countries like US, UK and European Union in achieving 6 km resolution. Because on an average in the world, currently 9 to 14 kilometers of resolution is going on, and 6 km is much higher than this average of the world. Then this system enables tailored short-range forecasts at the village and block level. So we will have the customized weather forecasting. And this system is also powered by supercomputers like Arkav, Arunika, etc. And this can track monsoons, cyclones and extreme rainfalls. So remember some of the facts on the Bharat forecast system. Then long period average. This is a rainfall recorded over a particular region for a given interval, that is like a month or a season. And these intervals, they are being averaged for a longer period of time, like 30 to 50 years. That means the monthly intervals are being calculated continuously for 50 years, and then the average is taken out of it. Then this LPA, the long period average, is a benchmark while forecasting the quantitative rainfall for that region for a specific month or season, and this average is based on the data which is collected for a period of 50 years, and it is being periodically updated for every decade as well. And then the Indian Meteorological Department has in the past calculated the long period average at 88 centimeters for the period of 1961 to 2010 and 89 centimeter for a period of 1951 to 2000. That means from 1951 to 1961 periods, so we have got 1 centimeter less of the long period average of rainfall. And for the whole nation, the long period average has been reducing from 1117 centimeters to 1116 centimeters. That means it shows over a period of 30 to 50 years, our rainfall amount is decreasing year by year or month by month. Then the LPA is needed because so the rainfall varies greatly from region to region and from month to month. And carrying a 50-year long period average, that will average out many unusual incidences like El Nino, La Nina and many others. Hence, we can get a very good average of that. And we have 5 categories of LPAs which is being maintained by the IMD, that is Indian Meteorological Department. That is, we have the normal or near normal rainfall, which is 104% of LPA, and below normal 90 to 96%. Above normal is 110%, which is more than normal. And then we have deficient, that is less than 90%, and in excess more than 110%. So no need to by heart all these things. So just remember that. So whenever we speak about normal rainfall or above normal rainfall, we are calculating that as per the long period average. Then coming to next, true polar wandering. This is a migration of magnetic poles over the Earth's surface through geological time. That means the magnetic poles, so they will shift, and there are also chances that they can reverse also. The North Pole can become the South Pole and the South Pole can become the North Pole. Polar wander is the motion of pole in relation to some reference time frame. It can be used, for example, to measure the degree to which Earth's magnetic poles have been observed to make relative Earth's rotation axis. Friends, this polar wandering is also used to measure how Earth's magnetic poles have been moving with relation to the Earth's rotation axis. So with respect to axis of rotation, how the poles are moving, north or south. So to measure this, so we are using the polar wandering concept. And it is also possible to use the continents as references and observe the relative motion of magnetic poles. By using the movement of the continents or the continental drift also, we can see how the magnetic poles are moving. And the motion of the magnetic poles will also give us the information about the movement of continents and how the continents are moving towards each other. That information also we will get. That means overall we can get a geologically significant information, that is how the magnetic north and south pole is moving and how other continents are moving and how the continental drift is happening. So overall, so here we can see that this is the actual rotation axis, so from North Pole to South Pole, and here we can see if this is the axis, so now your North Pole and South Pole, if it lies here, and that is an indication of the polar wandering. The wandering is happening like this. Yes, a very very simple concept, that is movement of the geological North Pole and South Pole of the Earth with respect to the physical North Pole and South Pole or the rotation axis. Then coming to next, friends, here is a question which is important to the rotation of Earth's axis. So here we saw that whenever we want the polar wandering to happen, significantly the plate tectonics should move, or might be the continents should move, and merely by the solar flares or the electromagnetic surge, so we cannot have the movement of the poles. So hence the rotation of Earth at its axis and also the movement of poles, so that will never happen because of the solar flares. We already discussed the question of solar flares. So here is a cross check that if we want the shifting of the Earth's rotation, if we want the shifting of Earth's axis to take place, it will never happen through the solar flares. It will happen only through a significant change in the plate tectonics or the distribution of density for that matter. So remember this point, and that will help you in solving this question as well indirectly. And then reverse faulting. Friends, a powerful magnitude earthquake of 8.8, so that struck near the Russia's Kamchatka Peninsula, and scientists believe that the quake has occurred because of the shallow reverse faulting. And here, what is this reverse faulting? Friends, the faulting usually occurs so in this fashion, that is, here we can see the plates moving away from one another, and hence the faulting is happening downwards. But the reverse faulting does not happen like this. Reverse faulting happens when the two plates are crushed against one another, and because of this crushing motion, so now the plate is moving upwards, and this is the reverse faulting. This is the downward faulting and this is the upward faulting. So that is why the name reverse faulting. So reverse faulting has a compression force and the faulting has an expansion force or a moving away force. So here reverse faulting or thrust faulting occurs when one block of the Earth's crust is pushed over another due to compressional force, not the extensional force. And the shallow reverse faulting occurs whenever the plate ruptures because of the compression, and that rupture is depicted on the Earth's surface. That means the rupture happens at a very shallowest depth or in the Earth's surface itself. And friends, this compressional force, so that can cause huge powerful shocks, and it can also trigger tsunamis, which also happened during the current Kamchatka earthquake. So these are some of the topics which are in current affairs. And friends, in geography, rarely things will be in current affairs, and if they come, be thorough with them. And coming to the last part, the only person you are destined to become is the person you decide to be. Ralph Waldo Emerson, friends, a very great thinker, R.W. Emerson. So he says that, so what you decide you become. So Rene Descartes also says the same thing. I think, so I am. So think, plan and prepare for that, so that you will live your dreamly life.